Hello, everyone. Welcome to the course EC255. In this first lab, we will be simulating some combinational circuits in a very lightweight software, which is called Logisim Evolution. We will upload the installation file on Canvas. If you download that from Canvas, it should look like this. So Logisim application file. So if you run it for the first time, this kind of message will pop up. So this application requires Java runtime environment. Okay, so if you do not have this, you have to just press OK. It will automatically direct you to the download link of Java in a browser. So in your browser, so I'll just click on the download Java for desktops, and I'll just download it. So after I download, let's click on this. Then you have to just install Java like a regular installer file. After installing Java, let's run the Logisim again. Okay, so it will open up. So this is the user interface for Logisim. So in Logisim, we will at first draw these circuits. So here in Logisim, you can draw logic circuits and simulate them. So let's draw this circuit first. I mean, this is a mux using not and or. Uh, so there are already this type of logic gates are already here, but you will also get them from here as well. So this is a kind of shortcut. So let's use the shortcut because we need and or and not get. So let's first start with a not get. So this is not. So if you click this and come back to the canvas, you will see that there is a not get symbol with your mouse. So place it somewhere. And then let's complete the circuit. So we'll need AND get here. So I'm taking one AND get and another one right here. So you can see that there are many inputs in this AND get, but we need only two input AND get. So we will just connect two inputs of this AND get, and we do not need to worry about other inputs. Just keep them as it is. Now let's draw the OR get. So we have OR get right here. So we will place it here, and then so we have all the components here. Now we'll just connect them. So the NOT get output is connected to the one input of the AND get. So to make a connection like here, we have to click on this. I mean, left click on this output. I mean, where you will start the connection, and drag, like keep clicking your mouse. I mean, the left click, and you can just release your mouse, and then it will start a connection from here. Then again, I am pressing the left click and connecting to the input of the AND gate. And yeah, so and another input of the AND gate will come from input A. Will be creating an input pin here. So to create an input pin, we have to just go to here. These are pins. So this is input pin and this is output pin. So let's take an input pin. So I'll just keep this right here, and I'll make connection to the AND gate. Now let's create another input pin because this is A, and we have two other inputs. So let's put input B, and let's make a connection. So this input should go to the input of the AND gate. I mean the second AND gate. So let me make the connection here. Okay, so I mistakenly made this connection. So I'll just select it and press delete from the keyboard. Okay, now we have another input. So let's take another input here, which is S. So this S is connected as an input to the AND gate. So let's make this connection to this input of the AND gate. And as you can see, I have mistakenly again made another extra connection right here. Okay. Let me select that and delete it. So as you can see, if you just draw connections and cross them like that, these two wires are not connected actually. So yeah, so if you just cross the wires, they will not be connected to each other right here. So there is no connection right here. So we do not want a connection right here. So yeah, there is no connection. And then let's complete the connections. So these S will be connected to the input of the NOT gate as well. So I'll start a connection right from here, right? And I will connect it to the input of the NOT gate. And then what else? I think the inputs are connected properly. Okay. And then the output of the first AND gate will go to the input. So I have to keep pressing the mouse and connect it to the input, one input of the OR gate. And again, I'll make a connection to the input to the other input of the AND gate, and there will be output. So there is an output pin right here. This is the output pin, the circle one. You have to place it right here, and you have to make a connection to the output. Okay, so this is a complete circuit. We have to actually name these inputs and output pins. So let's select this input first, and then we want to name it as A. Okay, because in the left sheet it is named as A. You can name anything actually. So let's select this input pin, and then come here. And there is a table, and here you can, as you can see, you can put a label here. So I'm putting A. Okay, and you will see that there is an A just beside the input pin. Similarly, you have to do this for B and for S. And you have to label the output pin as well. Here the output pin is G. So I am selecting the output pin and put a label G here. So this is the complete circuit that should represent a mux, two input mux. So now the question is, you have built the circuit, and now how to test this thing? Okay, so I mean, how to simulate the circuit. So by default, it's already in the simulation mode. So the result you will see, you are observing here. This is already the simulation results. I mean, if the input is A, I mean, if the input A is 0, B is 0, and S is 0, the output is 0, which is being shown right here. So now you have to toggle the inputs to see all available combinations. I mean, we have to make a truth table where you can see all the possible combinations and the results. So you have to make a truth table like this. So suppose this is one of your inputs, which is S. In Mux, S is actually the selector, right? Then you have two other inputs, which are A and B, and you have to make an output. Our output here is G. Now let's start checking the combinations. At first, we will start with 0, 0, 0. So already this is in 0, 0, 0 condition. The output is 0. Let's write this. And then let's change the inputs. So we want to see this combination 0, 0, 1. Okay. So the B will be 1. So to toggle the input right now, it's B is at 0. So if we want to change this, we have to enable this option. This is poke option. So you have to just select this poke option, and if you click on the inputs, it will toggle. I mean, yeah. So let's poke this B input. So if I just click it, it will toggle from 0 to 1. And then, as you can see, for this combination as well, the output is 0. Let's write this in the truth table. And then let's move to the next combination, which is 0, 1, 0. So in this case, B will be 0, and A will be 1, and S will be 0. So let's toggle the inputs. So A will be 1, and B will be 0. So right now, S is 0, B is 0, A is 1. Here, the output is 1. So let's write this as an output in the truth table. Now, what is the next combination? 0, 1, 1. So both A and B will be 1. So A is already 1. Let's toggle input B to 1. And as you can see here, the output is 1. So in this way, you have to check all the combinations. I mean, for this, you should have 2 to the power 3. I mean, 8 combinations like this. Okay. So this is how you check the truth table of a circuit, combinational circuit. So to save this project, you just simply go to the, as usual, so you have to go to the save, and you can just save it using any name, like a taste or a lab one, maybe lab one, part one. Okay. And it should save with a file extension name .circ. I mean, Logisim project. If you want to open this again after closing this software, you can just do that. And another thing is, for your report, you may need to submit the picture of this schematic. You can take a screenshot, but you can also use the export image option from the file section. So you can just export image as PNG, GIF, or JPG, whatever. So in task one, we have created a mask from the basic gets like AND, NOT, and OR. We have a ready-made marks in Logisim as well. So you will find that marks right here. So you have to go to the plexers, and you have to choose the multiplexer. And you have to just place it somewhere in the canvas. And then, as you can see, there are two inputs, input 0 and input 1. Yeah. So let's make some inputs. So basically, we are trying to make this circuit. So we have an input, so we need to connect this to one of the input of the marks. And we need to take another input right here, and we have to connect. We have to drag the wire to make connections, and then place another pin right here. And we need an output here. Then we have to connect these. And yeah, I think our circuit is ready because the mux was ready made. Oh, okay. So we have to also name these inputs. So let me label this as A. Let me label this as B, and let me label this as A. So select. Okay, now let's go back to the drawing board again. We'll just check that if it matches the truth table of the same marks that we created with basic gets. Here we are just doing that with the ready-made marks, which was already in the Logisim environment. And then let's, yeah, so for 0, 0, 0, as you can see, the output is 0. Now let's move to the second combination. Here's, so S is 0, A is 0, B is 1. So S is 0 already, so A is 0 already, and B is 1. Let's poke this. Okay, so at first you have to enable this option. And then as you can see, I made B equal to 1, then the output is 0. So this is matching with this truth table. And then let's move to the third combination where S 0, B 0, and A is 1. So let's make B 0 and A 1. And then as you can see that the output is 1, which is matching with the previous truth table. Now let's move to the fourth combination as well. Let's make S equal 0, A equal 1, and B equal 1 as well. So in this case as well, the output is 1. Okay, so in this way, you have to check all the combinations, like the 8 combinations. I hope you got it. And if you feel that these components are too small to see, you can I mean, zoom in right here. I mean, right now it's the scale is 100%. You can just increase it so that you can see it bigger. Okay, so now let's move to, this is task 2. And let's move to the task 3, where you have to make a full adder using these expressions. So let's create a new project. So you have to make a full adder, you'll need the sum, you need the carry. So to create the sum, so you have to do this operation. I mean, A XOR B XOR C in. Here C in is the carry in, and A and B are the two inputs. C in is also basically an input here, carry in. So let's build this circuit. So we will need XOR get. So if you want XOR get, they are not present in the shortcut here. So you have to go to the gets. And here you will find the XOR get. So I'm putting an XOR get here. So we will need actually 2 XOR gets, or you can use a 3 input XOR as well. So as you can see, there are too many inputs here. We will just use those input pins. We will have to use only 2 inputs or 3 inputs here. Okay, so let's take input pins and let's make connections. Let's take another input pin and make connection. And let's take another input pin because we have A, we have B, we have C in. Let's connect it right like this, okay? And let's name the input pins. This is A, this is B, and this is C in. Okay, and let's take an input pin, output pin as well, and connect it like this. And this should, let's name this S. So this should represent the sum of the A, B, and this carry in. And C, for carry out, we need to generate this function. So here, for A, B, let's write it down maybe. So the carry out is equal to AB plus AC in plus BC in. Okay. So to implement this function, what do we need? So to get A, B, we need an AND gate, right? So let's draw directly right here. So let's take an AND gate here. So the AND gate will take A and B as an input and generate AB as an output, right? So let's connect A. Oh, it's connected, as you can see. So whenever you see, I do not want to connect this A line to this B line, something like that. I was trying to make a connection from A to directly to B without connecting to B and C or something like that. So I wanted to cross this B and C without connecting with B and C, but it is connected. How I know that this is connected because there is a circle here, right? So this circle means these crossing lines are connected. So I do not want this. Let me just delete this for this moment. Okay, everything is messed up here. So this was like this. Let's take a connection from here and then here, and then let's connect it to like this. And let's delete this extra portion. Right now, as you can see, A is not connected to B or C because there is no circle right here. Okay, or here. Okay, so we have taken A from here and we need B as well. So let's make a left click here. Okay, let's delete this extra portion. So now this AND get takes A as an input, B as an input, and it will produce B in its output. So we have got AB. Now we have to make A C in. Okay, so we need an AND get as well. So let's take an AND get. Okay, and this AND get will take A and C in as an input, and it will generate A times C in at the output. Okay, so let's connect A from here. Maybe connect it like this. Okay, and then we need to connect C in as well in this AND get. And I'll make a connection from here, and this should give me the output A C in. Now let's move to the B C in. So we to get B C in, we need another AND get. So let's put an AND get right here, maybe right here. Okay. Now this AND get should take B and C in as the two inputs to it. Okay, so let's make a connection from here, here, here. So B as an input and C in as an input as well. So this AND get is taking B and C in as their as its inputs, and it should generate A as B C in its output. Okay, so we have got S and O. Okay, so and these terms, I mean, these terms are being produced by these three AND gates, and they how are they connected? I mean, there is a plus sign here, right? So you have to implement a plus sign. You need an OR gate, right? So we will take an OR gate and we'll connect them like this to implement the OR gate. Okay, so this OR gate takes these three terms and it generates the whole cout results. So let's take an output pin right here and connect it, and let's name it uh, cout. Okay, so I have named it cout. Now we have completed the circuit. Let's check the output now. So our outputs are S and cout, and our inputs are A, B, and C in. And in the left sheet, the truth table is already given. You have to just check it. Whether your circuit is working properly or not. So let's do this. So for the first combination where A is 0, B is 0, C in is 0, the C out should be 0 and H should be 0. Yes, this is the case right here. So all our inputs are 0, then sum is 0, C out is also 0. Then move to the next combination where C in is 1. So let's make C in 1. Oh, to toggle this input, make sure to enable this option, and then just make it toggle C into 1. And then you can see that sum becomes 1 and C out becomes, remains 0. Okay, so this output is matching the second combination of the truth table. Now let's move to the third combination where B is 0 and B is 1, A is 0, and C in is 0. So let's do that. So A is already 0. We have to make B 1 and C in 0, right? So we are simulating this third combination. So the result should be C out 0 and S equal to 1. This is the case here. So S equal 1, C out equal to 0. So far, our circuit is working properly. And then let's move to the fourth combination where A is 0, B is 1, C in is also 1. So A is already 0, B is already 1, C in should be 1 as well. So let's make it 1. And then in this case, our circuit generates C out equal 1 and sum equal to 0. Let's go to the truth table and check is it the correct case or not. So as you can see, it's the fourth combination. shows C out equal 1 and S equal to 0. So this circuit is properly, working as a full adder. So a full adder should generate this kind of truth table. Um, okay, now this is actually the task 3. Now let's move to task 4, where in the task 4 you have to implement the full adder using a ready-made built-in adder in Logisim. So let's make a new project, a new file. Okay, so here we will be implementing the same full adder using a ready-made arithmetic adder present in the Logisim environment. So you have to search, you have to go to the arithmetic folder, and here you can see the adder. So here, data bits is by default it's 8-bit. We need to just change this to 1-bit because we are adding 1-bit values. I mean, A is 1-bit, B is 1-bit. So we have to just make it 1 and then put it in the canvas. Oh, let's make it bigger. Okay. So these are the pins for this adder. If you hover the mouse on top of the pins, it will show what pin is it. So if currently this pin actually shows input, one of the numbers to it, which is A in our case, and this should be another input. If you keep your mouse cursor right here, you will see the instruction. So this is our A, this is our B, and this is our C in. Okay. So this is our carry in pin, and this is our carry out pin, and this is our sum pin. So let's take the inputs the same way we have done before. Making connections like this. Let's take another input and just connect. Okay, connect it like this, and let's name it to A, and name this B. And we should have another input pin with C in. So let's name it C in. And the rest of the pins are for outputs. The sum output. Let's connect the sum here and name it S. Okay. And let's connect another output to check. Okay, check the C out. Okay, let's name it C out. And here is our circuit ready. So let's check the combination again. So this should work exactly same as the circuit we have shown before with implementing these functions. So this is just a ready-made version in Logisim for a full adder. So let's check the combinations again. As you can see, A 0, B 0, C in 0. In that case, C out should be 0, S should be 0, which is the case right here. Now let's move to the next combination where C in is 0. Let's poke it to 1. And then in this case, the C out should be 0 and S should be 1. Here, as you can see, S equal 1, C out is 0. And in this way, you can check all the combinations. So this is it for lab 1. You can, from this tutorial, you can successfully, I hope you can successfully complete this lab 1 task. So thank you for listening to this tutorial.